Betelgeuse remains one of the most captivating astronomical objects in the night sky, not only because of its immense size and striking luminosity, but also due to the profound questions it raises about the life and death of stars. Situated approximately 650 light-years away in the constellation Orion, Betelgeuse is a red supergiant representing one of the final evolutionary phases in the life of a massive star. Its staggering radius, hundreds of times greater than that of our Sun, challenges human comprehension. If placed at the center of our solar system, its outer layers will extend well beyond Jupiter's orbit. This sheer scale, combined with its dynamic and unpredictable behavior, has made Betelgeuse a subject of intense scientific interest, especially as researchers strive to understand how matter and energy are recycled throughout the cosmos. In late 2019, Betelgeuse dimmed dramatically, dropping in brightness by nearly 40%, sparking global speculation that it was on the verge of going supernova. Although this did not occur, and later analyses attributed the dimming to massive dust clouds ejected from the star's surface, the event reignited international fascination. These vast outflows of gas and dust are part of Betelgeuse's ongoing mass loss process, a chaotic shedding of its outer layers driven by powerful stellar winds and surface convection. These outbursts are not merely precursors to the star's demise. They play a crucial role in enriching the interstellar medium with heavy elements. The calcium in our bones, the oxygen we breathe, and the iron in our blood were all forged in the nuclear furnaces of stars like Betelgeuse and later disseminated through such stellar explosions. Despite how much we have learned, Betelgeuse continues to guard many of its secrets, with scientists employing cutting-edge techniques such as astroseismology, the study of stellar oscillations, to probe its inner layers and listen to its internal activity. High-resolution imaging tools like the Very Large Telescope Interferometer have revealed never-before-seen surface features, including hot spots and turbulent gas flows, while the James Webb Space Telescope, with its unparalleled infrared capabilities, is now offering astronomers a clearer view through the dusty veil surrounding Betelgeuse, yielding critical data on its temperature fluctuations, ejected material composition, and surrounding structure. When Betelgeuse finally goes supernova, the resulting explosion will provide a once-in-a-lifetime opportunity for science. Core collapse supernovae are among the most violent and energetic events in the universe, releasing in mere days more energy than our Sun will produce over its entire life. Yet, despite decades of theoretical modeling, many aspects remain poorly understood. From the precise mechanism of a star's core collapse to the role neutrinos play in powering the blast, and how asymmetries influence whether a neutron star or black hole forms. Betelgeuse's death will serve as an unprecedented natural laboratory, with astronomers and physicists around the globe preparing telescopes, neutrino detectors, and gravitational wave observatories to capture every possible signal. The first harbinger will be a flood of neutrinos escaping the star's core hours before any visible light reaches Earth, an early warning that systems like the supernova early warning system will detect, giving scientists valuable time to reposition instruments like JWST, Hubble, the European Extremely Large Telescope, and the Vera Rubin Observatory to capture the event from start to finish. These coordinated global efforts promise to yield the most comprehensive dataset ever recorded for a stellar death, moving our understanding from abstract theory into real-time observation. Yet, the supernova itself will only mark the beginning of Betelgeuse's final chapter. The resulting nebula, composed of rapidly expanding stellar debris, will glow for decades, perhaps centuries, acting as a cosmic archive of the explosion's chemical, physical, and structural legacy. Should a neutron star emerge, scientists will study its spin, pulsar emissions, and magnetic fields, while the formation of a black hole would allow us, for the first time, to witness the birth of a stellar-mass black hole in real time. The aftermath will carry the fingerprints of the nuclear processes that unfolded in Betelgeuse's final moments, offering vital insights into how stars synthesize elements and ultimately deepening our understanding of how galaxies, planets, and life itself came into existence. While the scientific gains will be immense, Betelgeuse's cultural and emotional impact should not be underestimated. For millennia, people across civilizations have gazed at Orion's red shoulder and woven stories, legends, and tales of warriors around its enduring glow. Deities and cosmic power have long been tied to Betelgeuse, and its impending death reminds us that even the most enduring lights in the sky are not eternal. Once interpreted as divine omens, Supernovae are now recognized as essential events in the cycle of cosmic renewal, yet our emotional response remains profound. The thought that a star, long a fixture in the heavens and deeply embedded in human myth, could vanish in our lifetime stirs something within us, reminding us of our own fleeting existence beneath the stars. The very atoms that make up our bodies once belonged to stars like Betelgeuse, and observing its death is, in a way, witnessing a reflection of our own cosmic origins and destiny. The global scientific community is preparing meticulously for this moment. Neutrino detectors such as Super Cameo Candy in Japan and Ice Cube in Antarctica are on high alert to capture the earliest signals of the supernova. Gravitational wave observatories like LIGO and Virgo stand ready to detect distortions in space-time, and telescopes across the optical, infrared, ultraviolet, and radio spectrums are poised to document every moment from the first photon to the fading remnants. Public interest has grown alongside these efforts. The 2019 dimming sparked massive engagement across social media, classrooms, planetariums, and amateur astronomy communities. When Betelgeuse finally explodes, it will likely become one of the most widely observed celestial events in human history, transforming the night sky with a brilliance rivaling the full moon, visible even during the day, a spectacle unseen since Kepler recorded the last naked-eye supernova in 1604. Yet once the brilliance fades, the real scientific journey will begin. The expanding shockwave will help map the interstellar medium. Glowing remnants will reveal the nuclear alchemy that powered the explosion, and decades of study will cement Betelgeuse as a focal point in stellar evolution research. Scientists will refine classifications of red supergiant deaths, exploring why some collapse silently into black holes while others flare dramatically, and comparing Betelgeuse to its stellar kin will reveal the variables shaping these endings. Should a neutron star emerge, it will open a window into one of the universe's most extreme objects, while the birth of a black hole would let us witness directly the formation of one of the cosmos' greatest enigmas. Perhaps most remarkable is that we watch all of this in the past. The light reaching us now left Betelgeuse 650 years ago, in the medieval era, reminding us that the universe connects past and present. Its study is reshaping time-domain astronomy, a field focused on transient cosmic events, pushing astronomers to stay alert and responsive to sudden changes in real time. Advanced simulations are being used to model every stage of core collapse, and some even speculate that the 2019 dimming may mark the onset of a slow-motion transformation, a drawn-out death rattle unfolding over decades. If true, we are privileged to witness one of the most detailed case studies of stellar death in history. But Betelgeuse's impact will extend far beyond science. Just as the Crab Nebula supernova 1054 became immortalized in history and myth, so too will Betelgeuse inspire future generations through art, literature, film, and culture. Above all, it reminds us that the universe is alive with stories that unite us in awe, curiosity, and collaboration. In its final act, Betelgeuse will leave behind more than a glowing nebula. It will leave a legacy that connects science and humanity, proving once more that when the stars speak, we listen. Betelgeuse's impending supernova will be far more than an isolated event in space. It represents a pivotal moment in the evolution of modern astronomy, astrophysics, and international scientific collaboration. Unlike in centuries past, when the sudden appearance of a new light in the sky was interpreted as a mysterious omen, today's scientists are equipped with an unprecedented array of technologies working in harmony to capture every stage of such an event. We have entered an era where coordinated multi-messenger astronomy, combining light, neutrinos, gravitational waves, and even cosmic rays, has become not only possible but essential. The death of Betelgeuse will be the ultimate demonstration of this synergy, offering the chance to test, refine, and even rewrite fundamental models of stellar collapse and element formation. Space agencies such as NASA, ESA, and JAXA are already pooling resources and developing contingency plans, reflecting a new standard of global cooperation where data transcends national boundaries and is shared openly for the collective advancement of knowledge. In this evolving network, researchers, observatories, students, and even amateur astronomers play vital roles. Citizen science has never been more relevant. Backyard telescopes and home observatories now routinely provide data for professional research. The 2019 dimming of Betelgeuse highlighted this beautifully, as countless amateur images from around the world were compiled into brightness models that monitored the star's surface changes in unprecedented detail. This collaborative spirit has also fueled the rapid growth of time-domain astronomy, which focuses on monitoring changes in the sky that occur over hours, days, or weeks. With the rise of wide-field surveys and automated monitoring systems, such as the Vera Rubin Observatory's Legacy Survey of Space and Time, LSSD, astronomers can now receive real-time alerts within minutes, triggering cascades of follow-up observations worldwide to ensure no critical moment is missed. At the same time, Betelgeuse is forcing astrophysicists to rethink long-standing assumptions about red supergiants. Its irregular pulsations, temperature drops, and massive outbursts suggest our models of stellar convection, mass loss, and late-stage fusion remain incomplete. How do convection currents behave inside such a colossal star? What determines whether it ends as a neutron star or collapses directly into a black hole? How do magnetic fields and rotation shape the symmetry or asymmetry of a supernova blast? Each new anomaly from Betelgeuse is more than a mystery. It is a clue to some of the most profound questions in astrophysics. Yet beyond data and equations, Betelgeuse's story is deeply symbolic. Throughout history, it has appeared in myths across cultures as the shoulder of a hunter, the heart of a warrior, or a herald of seasonal change. Its eventual disappearance will not just be a scientific milestone, but a cultural moment, much like humanity's first steps on the moon or the return of Halley's Comet. Billions of people across the globe may look up together, witnessing the same extraordinary light, perhaps for the last time, a rare moment of unity in an often divided world. Educational institutions are already preparing. Curriculums are being updated with modules on supernovae, time-domain astronomy, and stellar evolution, while classrooms run simulations of Betelgeuse's death to prepare students for what they may see with their own eyes. Museums and science centers are developing interactive exhibits and outreach programs designed not only to inform but to inspire, ensuring that Betelgeuse's final act sparks the curiosity of a new generation of astronomers, engineers, and dreamers who will carry forward the legacy of discovery.